was a lot of thought put into what we should do for you during this lunchtime. Certainly the idea for doing what we're going to do now did not come from me. What we're going to do is a fireside chat. So somehow the name The Founders came into being. I would like to now invite some of the founders up to stage. When I say some of the founders, unfortunately Roger Penrose, who was one of the founders, couldn't come. As you noticed, he's pretty lively, but he's also 91 years old. So could I invite Frank Gistra, Marcus Friend, Terry Hui, Paul Lee, and Mo Kamani to come up, please, and we're all going to have a seat. Maybe I'll sit here. Oof. Thank you. I don't think I'm going to use this. I'm going to use this. Yeah. So I understand that we have here a very wide cross-section of people in Vancouver, ranging from people in the business community to people in the general public who are interested in science, to students, and here and there, the odd physicist. So a question that keeps on being asked to everyone is, why on earth are you doing this? How did it all start? So I'm going to actually ask this question to everybody on stage, and they're going to tell you their personal point of view on the whole thing. But of course, that means that I should probably give my own first. So I'm going to be very brief. Back in 2013, Roger Penrose and I were trying to figure out a way of collecting, classifying, and making available to the world what is actually the largest scientific archive in the world. As was announced, I think, in the press last night, we've succeeded. And we will be, in fact, one of the things that the Quantum Gravity Society will be doing is actually, well, we've acquired it, now we're going to do the rest. But other ideas came along, and to cut a long story short, back in 2019, Paul Lee and I were sitting with Roger in a restaurant in Oxford, and this was another one of those marathon lunches. It wasn't quite the 6-hour lunch that Terry and I had the other day, but it was almost as long. And on the basis of that, actually, the idea of having the Quantum Gravity Institute was cooked up. The Quantum Gravity Society was rapidly formed. It became a charity in the US a long time ago. It became a registered charity in Canada yesterday. And we all met, that is to say myself, Roger, Frank, Paul, Terry, Mo, not Marcus, I think you came to the next meeting. We all met on Terry's yacht back in November 2019 to decide how to do this. And then, of course, COVID struck. So that's why this event is happening now rather than earlier. But this is my point of view. I'm enormously pleased that a collection of people from the business world who have managed to show me the most incredible enthusiasm for this project, which, let's face it, is not obvious. The idea that quantum gravity will save the world is not obvious. And I'm sure a lot of you are sitting there wondering why on earth we would come up with such an idea and why any of you should believe it. So I think I'm going to now ask some of the people, and I'm just going to go from my left to my right. So Frank, how did you come to be involved with the Quantum Gravity Society, and why is it that it excites you so much?
Okay, thanks, Philip. I've always been amazed by what can be achieved by man's curiosity. And I'm a I'm just curious by nature. I never studied physics in school. I took it up about 20 years ago just by starting to read some books. And the more I read, the more interested I became. And as I said earlier in my speech, it's a huge rabbit hole. Once you go down it, you'll never come out because it becomes more and more interesting. And I manifested meeting people that were like-minded. I thought, I wanted to meet Brian Greene because it was the first book that I read, so I met Brian Greene. And then I met Paul Steinhardt from Princeton, and eventually I met Philip Stamp. And that's how I got involved in this group. But the real reason why I'm interested in this is because, as I used to tell my children all the time, just to give them a sense of what is possible in a man's lifetime I talked about the TV show Star Trek that I used to watch in the 1960s when I was about 9 or 10 years old. And I remember Captain Kirk talking to a computer, and that computer in a woman's voice would talk back. And I used to think, yeah, as if that will ever happen. And his communicator, which looked like a flip cell phone. And I thought, and here I am, in my lifetime, those things have happened. And what I honestly believe is that if we ever get our heads around quantum gravity, this world will change in ways we can't even possibly imagine. I wanted to be part of it. It's as simple as that.
Mo.
I'll use Frank's. I studied a little bit of physics, but I was never a theoretical physicist. I avoided all theoretical physicist classes as much as I could. But I met Philip, and I think we had a discussion about the Michael Wright collection. And to me, having digitized interviews and record of past scientific works is really important for two purposes. The first purpose is maybe the experts can look back and learn something from them. But the second purpose is maybe by reviewing the records, we can inspire another generation of young people to embrace physics and to go and study physics, because scientific progress is nonlinear. You have periods where nothing happens, and then you have periods where lots of things happen. And you need a lot of youth and continuous people going into the field to explore the ideas. And I think in science and in physics, when you read a paper, that's the culmination of somebody's work. The paper tells you what it is that they arrived at. It doesn't tell you what they were thinking when they arrived at it. And I think the Michael Wright collection, by virtue of the interviews that are present within it, give us not just where things ended up, but how did people come up with them, how did they think about them, and the interviews are really compelling for anybody, for example, that's ever listened to the interview of Richard Feynman about how fire works. It's probably, if he wrote that on a piece of paper, it wouldn't be as compelling. So I became involved because I was very passionate about preserving the records of the scientific work done on gravity and making those accessible to the scientists as well as the non-scientists for being able to draw inspiration from.
Thank you, Mo. So Terry, during these endless lunches that we've been having, and during your studying at 6 a.m. in the morning, you probably come to an answer to this question.
Well, the first lesson I learned is this. When I come to the event, I met with like a lot of the top women physicists, and like Nata Lowe, like Suzanne Steck, and like Birgitte Wally. So the first lesson I learned is this: science is not a man's world. Now, this is like, Mo talked about it's not theoretical physics. So whenever I come to the math, I sell out much earlier. I have only an undergraduate degree, and I switched to engineering. He has a PhD degree. So he's being humble, right? And by the way, Frank and Paul, at the time I interact with them, their passion and ability to acquire knowledge is unbelievable. I have to learn from them. And Mark is always the smart one. So I don't do. Anyway, for me, it's like, this is like the guy who never make it into the high school hockey team, going to get to hang out in the Canucks locker. So watching Philip and Jim, Jim Peebles, our very own Canadian Nobel laureate, and Slava, and Bayer, and Bill, having heated discussions, it's like amazing. And I also see that a lot of the next generation scientists in this room, when I was there, like Clifford, Yan Bei, and too many to mention. Robert, right? Dan, but I call him we call him the theoreticalist with the experimentalist mindset. But whenever it comes to math, I'd rather be in the bar with Marcus Esfermeyer in the bar, talking about his levitating glass beads, right? But anyway, joking aside, right? I think I have my bankers here, so I have to show them that I'm not crazy, right? I still want to maintain my credit rating while I'm doing all this, right? So I don't know. I mean, I just want to do this layman's gap on, as an undergraduate student, I always complain that you learn all this stuff, you don't know where you're going. So I want to do this, okay? I think one of the things that, Philip, when you talk to me, that really attract me to this is the mix of theorists, experimentalists. That's very visionary, okay? And so I see physics, one of the things we're trying to do is to have a mathematical model and theories that accurately describing our world in a situation and make prediction that's true for a large range of situations. But the only problem is that we're not building locomotives anymore, right? So it's like a train has to work from this speed to that speed, and mostly Newtonian forces, okay? So now we're dealing with a more complex world, right? We're dealing with like the dimensions, not just force. We have electromagnetism, we have time, space, and a lot of things, strong force, weak force, I mean, just to talk about it, right? And then, so the parameters we're dealing with is bigger, and the range is much bigger. No longer from 0 to 100 miles. We're going from, like the range is like to particle to black hole. So the search for the solution from the theorists becomes much more difficult. It's a big, vast field, right? So I just want to describe the challenge a little bit and what we're trying to do, right? I'm not a scientist anymore. I don't want to pretend to be one, right? And I think the idea of marrying experimentalists so you can actually have more data to narrow the search field is important. And all these tools, like the predictions and a model, helps us in the real world to design things and build things, right? Like a train in the old days and other things, right? It's important. So I think, and also for the Institute, I think in terms of, we don't want to be duplicated at the effort. I think to have something like, to be able to sit next to Kip is a privilege. And like LIGO, like if you have a project to do, it's much easier. So Philip tell me collaboration is much harder to get funding. So for Vancouver to be a place for the scientists to meet, to design these experiments perhaps, before there's funding, I think is invaluable. And to sell Vancouver a little bit, we are a great city, right? So having all these great minds in our city, I think will benefit us. These guys are the top of the food chain of the knowledge industry. So have them in Vancouver, I think is invaluable. And World Wide Web, as you know, is like developed by CERN. So there are a lot of other things that will come with it. I talked too much already, so maybe I should pass the mic to Marcus.
Thank you very much, Terry. Marcus, over to you.
Yeah, so I first got involved when I had a couple of dinners with Paul and Mo a couple of years ago, pre-pandemic, when life was much simpler. And, this is something that really appealed to me because, this can solve some of the world's problems that we have. We just don't know what ways. And every time there's been a theory like this developed, there have been an incredible amount of technology that's come out of it. But not even, even if we don't have a theory currently, just the ways we're developing experiments and the sensitivity of the detectors we're using have broad applications across a variety of industries. And I'm used to investing in companies and building companies that change the way things are done. And for me, when I look at this, it's like, this is something, no matter what happens, will fundamentally change the world in the future as we know it. We just don't yet know how that will happen.
Paul.
Well, Philip sort of told you how we got going on this in a meeting in Oxford. So I guess what I'd say is, why Vancouver? And I know we get this all the time, why Vancouver? And it's weird. Vancouver is like one of the world's best cities. And nowhere else but Canada, in any great city, do they ever ask, why New York? Why San Francisco? Why London? It's only in Canada do we ask why. So maybe it's because we can. And, you know, now the light's my eyes, but I look out here and I see Jason McLean or John McBain or Francesco. I know Ryan's here. I see Robin Lewis and Haig. And, you know, all these people can live anywhere in the world. And they choose Vancouver. And it's because it's a great place to live. And if you want to go collaborate somewhere, like, look outside. Vancouver's just so phenomenal in the summer. So why Vancouver? Because we can. And I think, I sort of went through this. I ended up with Frank and Marcus and Terry, and we were sitting around, and they said, yeah, why not? Like, we can make this happen. And I thought, oh, good, because, you know, I hang around with a bunch of entrepreneurs. They come with a whole bunch of ideas, and truthfully, we don't fund a lot of them. But the reality is you get kind of, like, excited, and you end up thinking you're one of them. You come up with all these dumb ideas, and most people tell you it's dumb. And these guys said, actually, we can make this happen. So that's why.
So perhaps I can summarize what you said, Paul, by saying we should stop asking why and start asking how and get on with it. And with that remark in mind, and also recalling something that Terry said, I'd like to ask people if they could know who said the following. If you want somebody to talk about something, ask a man. If you want somebody to get something done, ask a woman. Does anyone know who said that? Margaret Thatcher. And the simple fact is that the two people who have made this conference possible are Swan Rai and Lara Dauphiné. Are you there? Can you stand up, please? I don't see Swan, but that's probably because she's off doing something. Oh, she's over there. Okay, very good. Okay, so we really owe an extraordinary debt to both of them. I'll just finish, because I see I have 3 seconds left, by remarking that Margaret Thatcher talked a lot. She's very quotable, but unemployment in the UK, if there are any Brits here, went from 800,000 when she began to 5 million when she was kicked out. So we are not going to make that mistake. We're going to get things done. Thank you very much.